Hey YouTube, it's Dimitri, and today I wanted to talk about model use cases and understanding how a model is used can impact absolutely everything on the model. More importantly, it can determine if a model is working or not working. So how you use the model is critical. The model itself might be perfect. It might be amazing. It's this beautiful thing on the quant side. But if someone's not using that model correctly, it can make the model seem like it's failing. And so explaining, training, and educating the back and forth conversation between how to build the model so it meets the user's need and the user explaining what they're doing and how they're going to use the tool to the developer so it develops something properly here. So the takeaway from this video is that model usage and how it's being used has critical impacts on the monitoring, the development, the accuracy, and how a model is actually going to work into practice here. So we're going to use a time series example here. These tend to be a little bit easier to understand. And I'm going to tell you we have two different models here that we're going to look at today, or more or less two error metrics. So let's say we have model 1, and model 1 has a 99.85% accuracy, and model 2 has a 71.35% accuracy. Now the question is, which model is a better model? Now I know the quants out there that are doing this a lot, you're gonna be like, well, it depends, and there's a lot of things because you already know what's gonna happen with this video. But those of you that don't know, these are actually the same model. And so I'm going to show you here, depending how you use the model determines how you do your model's accuracy assessments, as well as a bunch of other metrics can go into this. So hopefully you guys think about this and go, wow, this could be done on all these other metrics and measures. You know, is it robust? Is it accurate? How's it being used? What is the use case? Like, how do we adjust the strategy? All these things are impactful. But let's just say we're going to do a very, very simple model here. And again, a huge disclaimer, this video is not to explain to you how to do time series modeling. It's not to give you the world's most creative, intricate example of real world data and modeling. I'll put a video link above or in the description below on my time series videos on how to build time series models, and how to do stationarity testing, and how to assess white noise within the residuals and all that sort of thing. But let's just say that we have an AR1 model. So this is going to be the prediction of today. Basically, what we're going to predict for today is going to be equal to beta 1 y of t minus 1 plus epsilon of t. So this is the model residual. This is what we're off by. This makes this balance. And then this is going to be yesterday, which is y of t minus 1 multiplied by some sort of scalar coefficient here, is going to predict today. And I'm going to make this even simpler. So this is an AR1 model, if you're curious. I am going to make this a pure unit root model, which I know many people don't know, but essentially this beta coefficient is just going to be equal to 1. So this would be y of t is equal to 1, which is the beta coefficient, times y of t minus 1 plus epsilon of t. And that gives us our final model, which is today's value that we're predicting, whether it's price or, I don't know, metrics or, I don't know, some sort of value that we're predicting here is equal to y of t minus 1 plus epsilon of t. So more or less, yesterday's price is going to be our best guess prediction at today's price. So this is going to be our final model here. Now, I'm going to tell you the windows on these are different on the predictions up here on the model errors. So let's say that this is a 1 period window of use case, and this one's going to be a 10 period window. So imagine now we have this time series and it looks something like this, you know, I don't know, something fairly standard and normal. And what this is saying is that whatever the value was yesterday is going to predict whatever the value is today, okay? And so we say, okay, we're going to predict the next value is going to be straight across. So if we were going to get to the end of this time series here and we say, okay, this was yesterday's value, I don't know today's value, I'm just going to predict it being here. You can see when the actual distance of that prediction window is small, this time series, the actual forecast of this, is just going to be shifted. So yesterday's value is going to be today. So it's essentially this green line all shifted over just one period. So it would look something like this, where you're essentially just shifted. Oh, and it's supposed to be in front of it. But you're going to be shifted over, and this is going to be more or less like a process here that's kind of like mimicked in this. And this is very overly simplistic, but you can see the model error between this one period is going to be very small. Now, if I said, okay, this is today, and I'm going to forecast out 10 periods, you can see the model error is going to be much bigger, especially when we have some sort of run or something in the data. So like if you're predicting from here and you have to predict out a 10-day window, say like here, when you forecast this, right, this error would be huge. Whereas if you're just doing a 1 day period, like you're predicting down here, the errors are going to be much, much smaller, or the residual itself is going to be much smaller. I'm going to interchange error and residual. Error means an actual, if we knew the actual, so residual is technically the proper term here. But you'll see here that the window changes that. Now, the model we're using is this model here. It's this perfect AR1 model. The model's not changing. Mathematically, the quant is telling you this is the model, this is what you need to use. Now, depending if you're using the 1 day window or the 10 day window or period window or a 20 period window, whatever the window is, that is going to drastically change the actual model error calculations. And I'll assume these are root mean squared errors just for simplicity's sake here. So you can see the window is critical in what you select and how you use it. Now, getting into the backtesting, I just want to show you a little bit of the complexities of how this gets constructed and put together. So we're just going to say backtesting. And this will matter a lot because you can have some sort of series here as we talked about. And what we're going to be looking at is that you want to have some sort of development period. So this is what you developed on. This is your model. You could do essentially true backtesting and test backwards. Most things I do, I test forwards. But you would have like today here. This is your development, also called training in the machine learning world, and you could split and have a validation period. I don't really care. We're not doing machine learning. We're doing statistics. And so this would be our what's called our out of time. This is data we've never seen, we've never built on, we've never tested on. None of this data in this section here has ever been seen by this model in our estimation procedures. Now, if we were going to be doing this, you would have to figure out how you're going to do the errors on each time period, and this can get a little bit complex, again, depending how you're using the model and depending what you're wanting to look at with this. So let's say you had the 1 period. This is pretty easy. So this is today, or this is yesterday, and we're predicting today, and it has to be flat because it's an AR1 model with a perfect coefficient of 1, and we'd put this here, and then we'd wait to see like, okay, this is going to be down here, and so you're like, okay, the model error is going to be this little gap here. And so you would have your residual, and your residuals in this case, the first value would be like negative 0.0001. And then what you'd end up doing is saying, okay, let's do the next period here. And if the next period prediction is going to be starting here, right? So now you're assuming, okay, we're updating our knowledge base. We're going to predict out the next value is going to be here. And then this next value is here. So it has like this. Now we're going to calculate this little spot, and we would add in our next 0.002. Something like that. And then you'd go through and use all this data to calculate out like your mean squared error, okay? This case is fairly straightforward with the 1 period prediction here. If we erase all of this and go back, if we're doing a 10 period, there are different ways to do this depending on technically what you can and can't do and how you're using this. You could say, okay, we're going to look out just 10 periods. So we're going to go out and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to predict out this stream of values, which is going to be all these different values out to 10. And essentially it's going to be a flat line. Okay. So you predicted out 10 periods. Yes, this is a pure AR1 model. You would just take your prediction of the next period, and that would be the prediction of the next period, and just be flat. And then depending on what this data does, these data points, you could then look at 2 different ways of doing this. The easiest way to do this is saying, okay, once I make a decision, today, I cannot make a decision for 10 days or 10 periods. And you would just take the gap between the dot, what your prediction is, and the actuals here. And again, you'd have residuals, and you'd have like negative 0.005. Something that's going to be a little bit larger here because the window is larger and it drifts a bit more. Now, you could also try to find, depending if you could make decisions in the middle. So maybe you're trying to forecast a 10 period window here, and out of this 10 period, you could technically rebalance or do some sort of trade. Or if it's a different problem, like, I don't know, make some sort of consumer adjustments or decision-making process. You might want to try to capture all of this area inside of here and then figure out how to aggregate that. Now, in this example, right, this is all going to be this negative residual calculation of area here. But if it started to cross over and you had ups and downs, you don't want to just take an average because that's going to botch all this stuff up and it's going to pretend like you have great prediction when you don't. And it's very, very misleading here. So again, you need to think about how you're going to do that because you might end up calculating all these errors in here, which we're talking about, and then having an aggregation method to do that. And then that all needs to get aggregated into this period as of, say, t. And that's going to be some sort of value up here. So this is t. And then t plus 1, you would then need to come up with some sort of way to aggregate those to that, or just doing the 10 window period to calculate out. Let's say, like, I don't know, this is like 0.02 now. It's gonna be the next period. And then once you could finally do all this, you could do root mean squared error, and you could do that process here. But I hope you guys realize, like, how you use the model affects how the actual model metrics and performance are measured and monitored, having some sort of strategy on this. The other takeaway I want you guys to realize is how your pricing and strategy team, or how your operations team, or whoever is the end user of this model, how they determine to use it will impact how the model is actually performing. Okay, so if they're using it on a 1 window, a 2 window, a 10 window, that's one issue. Now, the other issue, which I didn't mention, is what we often have model overlay. And model overlays are a huge crux and a huge issue, because somebody will come along and say, okay, this is the green forecast. We don't really like that. We think it's really going to be here, and we want the forecast to look like this, and they'll do some sort of overlay on top of the model here. This is where you come into things, I'm going to call this model governance, or more specifically, this is risk management, which is really what's happening. And risk management is really going to tell you who owns the model, right? Because in this case, right, you can see I have one mathematical equation, and I am not changing my mathematical equation. I built this math. But the question is if the end user uses it incorrectly or improperly, or changes their strategy of how it's being used, somebody has to assess what's going to happen in that model and how you monitor and manage the assumptions behind that model. If I built you like a 1 period prediction model and you're using it for a 10 period, my model errors might be huge, and I should have maybe specified something different. Like, just off the top of my head, it should have been a y of t is equal to a yt minus 10, or a yt minus 5. Like, there might be some sort of adjustment here where you're like taking a data point here, and you're sitting here today, and you're going to forecast out, and you think that you're going to end up with a value back over here. Again, I don't know. You have to go through this theology here, and you might have a beta coefficient, and then of course you would have, y of t minus 2, and you might have a bunch of other complexities that go into this model point, because you're trying to get to something that is realistic with the relationships and the timing of how that model is being used here. So I hope you guys have this takeaway. How you use the model impacts how you test, monitor, perform, and engineer the model, the data used, the model type that's used, how the estimation is done, and more importantly, how the performance of that model is going to be checked here. So if you guys found this video helpful, please do like and share it on LinkedIn, YouTube, other socials, Twitter, X, whatever. It really does help grow this channel. Thank you for watching, and as always, until next time.